All right, we are starting our first unit for, or first section for our next unit. Section 4.1, operations with polynomials. The essential standards. I can understand and use the rules for exponents to simplify expressions with exponents. I can perform dimensional analysis using the rules for exponents. It is essential that you understand the rules for exponents. It is insufficient to memorize the formula if there's limited or no understanding. So an exponent is just a shortcut method of writing a repeated multiplication. For example, a times a, and so forth. There's 6 of them can be summarized by a to the 6th. The exponent tells how many times the base was multiplied. Additionally, the concept of a negative exponent is a logical extension of this repeated multiplication principle. See the following table. So let's start from the right side of the table and move to the left, and you'll notice the pattern. So if I have a times a times a, it's the same as writing a to the 3rd. And if I have a times a, it's the same as writing a to the 2nd power. If I have a single a, it's the same as writing a to the 1st. Here's an interesting one. 1 is the same as a to the 0. Okay, so any number to the 0 power is equal to 1. Now we have a to the negative 1. Well, that's the same as 1 over a. So what we have done in each situation is counted the number of a's. Okay. So if I have 1 over 2 a's to a times a, it's the same as negative a to the negative 2, and so forth. So we see the pattern. A to the minus 3 is 3 a's multiplied by each other in the denominator. Okay. So that's an expanded exponential form, and this is the expanded. This is what it looks like to expanded. This is the simplified. All right, so there are some rules, and you've seen them before. If we multiply, sorry, if I have multiplication with the same base, so notice the x's are the same, so x to the a times x to the b, I add them. And so here's an example, x to the squared times x to the 4th. If I actually wrote them out, I would have, there's my x squared, and then I have 4 more x's, and if I add them all together, I'd have x to the 6th. So if you forget the rule, you can actually remind yourself of the rule by writing it out in expanded form, and then you can quickly, I hope, discover the rule. All right, division with the same base. I have x to the a power over x to the b power. This is where we subtract the exponents. So here's one with expanded form. So if I have x to the 5th, I have 5 of them in the top and divided by x squared. I have 2 on the bottom. What did I have to do to have, you could actually see that I would cancel 2 of them, and I have 3 left. So what would I have to do to get x cubed in the top? Well, I would have to subtract. So if you forget the rule, that's an easy way to kind of remind yourself of the rule. Negative exponents, let's see if I can talk. X to the minus a is the same as 1 over x to the a. And if I had 1 over x to the minus a, it's the same as x to the a. So let's look at what that means. Here's some examples. They tell us, essentially, I just reverse it, right? The negative exponent just means I flip it, all right? Now, bases with exponents raised to an exponent. Okay, so let's take a look at this. So in the parentheses, I have x to the a power. And then I take that to the b power. So I have to multiply a times b. So if you forget, let's see how we can actually remind ourselves what that looks like. I have x squared, there's what's inside, and I have 3 of them. So I have 1, 2, 3 of them. And then I can figure out that I get x to the 6. And then you could ask yourself, what did I have to do with the 2 and the 3 to get 6? I had to multiply. Now, if I have, this applies whether or not they're the same base or not. I would still multiply this c times b and c times a. So here's what that would look like. X to the a times c, y to the b times c. In the similar fashion, you could figure out the rule. How many of these x cubes times y do I have? Well, I have 3 of them. There's 3 of them. I now need to add all these x cubes to each other, and that's how I got 9. So if you forget the rule, you can try to use a simple explanation off to the side, and maybe that will help you remember the rule. This also applies if they're divided. So notice I have x to the a power over y to the b power. That c is going to get multiplied times a and times b. And this is what you're going to get. X to the a times c, y to the b times c. So here's an example. I have x to the -4, but I'm going to take it to the -2. So multiply -2 times -4, and I get a +8. If I take that -2 and multiply it times a +2 for y, I get -4. And then, of course, I would flip the y to the top to get the 4 positive, okay? A 0 power. Any number to a 0 power is equal to 1. That's assuming the number is not 0. So, for example, a times b squared to the 0 power is equal to 1, because that 0 will go and get multiplied through both of them. I'll have a to the 0 power, b to the 0 power, and both of those are going to equal to 1. Continuing on. An expression containing exponents is considered simplified if there are no parentheses, bases with exponents raised to another exponent, negative exponents, and 0 exponents, and bases appearing more than once, and all fractions are in simplest form. So that's a lot to unpack there, okay? So let's do some examples, and let's kind of develop a procedure. So I have a -2, and I'm going to have to multiply. That's 2 to the 1 power times -2. So now I have 2 to the -2. I have a to the -2 times 3a cubed b squared c to the -2. So how let's deal with the 2 to the -2 first. Well, it's -2, so it's 2 squared in the denominator, which will be 4. Then let's deal with the bases that are a's. So I have a to the -2 and a to the 3rd. I can add those two. So 3 plus a -2 gives me a +1. And so I would get a, and that would be the result of simplifying that. I still have this 3 that I have to leave on top, so we'll leave that there. I have b squared and I have c to the -2. C to the -2, so I'll put that on the bottom. C to the -2. And I have, I will confirm that I have met all the requirements. I don't have any additional A's. Everything looks good. Whoops, I see a mistake. That's not C to the -2. That is C to squared. We got rid of the negative by putting it on the bottom. And this is the answer. All right, why don't you try one yourself? Welcome back. So the first thing I would do is look at my Q's. So I have Q to the squared over q to the 7th power. So we have to subtract. So I have q to the minus 5. I have r to the 4th over r cubed. So I'm going to get r to the 1 power. I'm not done. I can't, this is not simplified because I have a negative exponent. I cannot have that in simplified form. So how do I get rid of the negative 5 as an exponent? I have to put it on the bottom and then the 5 becomes positive. So I have r over q to the 5th power. All right, let's continue on. So I have a parentheses. The first thing that I would do is take that 3rd power and multiply it times every single power that is within the parentheses. So I would have negative 2 to the 3rd power, a to the 12th power, and b to the 6th power. Negative 2 to the 3rd power would be negative 8. So negative 2 times negative 2 times negative 2. I have 3 of them. And the rest is simplified already. All right, let's try again. One yourself. Don't let the parentheses fool you. I can write this just like this. There's no additions. So the first thing that I would do is combine my 2 and my negative 7, and that would give me negative 14. Then I would come and combine maybe my x's. So what do I have? I have x to the 5th and x to the 3rd. So add them, and I would get 5 plus negative 3 gives me a positive 2. Then I would combine my y to a 3rd and my y to a minus 6th. So negative 6 plus a positive 3 gives me negative 3, and I would have to put that on the bottom to get the negative exponent to be positive. So I'd have negative 14x squared over y cubed. All right, so multiply the negative 3 through. A to the minus 3 over 4. I'm not sure, sorry. I lost my train of thought. So 4 to the minus 3 power, sorry. Okay, so I've multiplied through the parentheses with my negative 3 exponent. Now I've got to simplify. So that is equal to 4 cubed on top, a cubed on bottom. Well, what is 4 cubed? 4 times 4 times 4 is 64 over a cubed. Why don't you try one yourself? All right, welcome back. I would take 15, divide it by negative 3, and that gives me negative 5. I would look at my c's next. I have c to the negative 5th over c to the minus 8. Negative 5 minus a negative 8. So negative 5 plus 8 will give me c to the 3rd, which is a positive 3, so it's going to be on top. Then I would look at d's, and I say d squared, so 2 minus 6 is a negative 4, which means it's going to be on the bottom, and that way my exponent is a positive number. Okay, let's do the next one together. First thing I would do is look at my negative 12 divided by, or over 36. So I can reduce that, right? I can have 4. 4 is a common factor for 12 and 36. Actually, 12 goes into 36. So we can actually say, all right, 12 goes negative, 12 goes into negative 12 one time. So I'm going to leave my negative. 12 goes into 36 3 times. So I have 3 on the bottom. Then I have my ends. n to the 7th, n to the 4th. I also have n squared. So n to the 7th times n squared, I've got to add that. So I have n to the 9th. 9 minus 4 is n to the 5th. So that'll be on top. Then I have p to the 5th, p to the negative 1. I have to add that. That leaves 5 plus a negative 1 gives me p to the 4th. P to the 4th minus, so 4 minus 9 gives me p to the 5th, a negative 5, sorry, and that means that it has to be on the bottom. Okay. Try one again. Welcome back. I would take and multiply everything by that negative 3 first. So that negative 3 has to be multiplied by every single exponent. So what does that give me? That gives me 5 to the minus 3, a to the positive 21, b to the minus 6, a to the minus 3, b to the positive 6. Okay, now I can simplify. So 5 to the negative 3 is the same as 1 over 5 cubed. So what is that going to be? 5 times 5 times 5 is 125, and it's on the bottom. Okay, that gets rid of the minus sign in the exponent. Then I'll look at my a's. I have a to the 21st over a to the minus 3. 21 minus a minus 3 is 21 plus 3. So that's going to end up on the top, and so that'll be a to the 24th power. B to the minus 6 minus a 6 is now b to the minus 12. So that is going to be b to the 12th on the bottom. And this is simplified. Continuing on. So let's look at our integers first. So I have 8 over 24. 8 can go into 24 3 times. So I would have 8 into 8 is 1. 8 into 24 is 3. Let's look at our a's. I have a to the minus 3 minus a 1. Now I have a to the negative 4. And so to make that a positive exponent, I have to have it a to the 4th on the bottom. Then I have b to the 6th minus, so b to the 6th over b to the squared. So 6 minus 2 is 4. And so I will have b to the 4th. All right, your turn. Welcome back. I take this 5 and multiply it times each one. So what does that give me? I get negative 2 to the 5th power, x to the 15th power, y to the negative 10 power. Now let's evaluate each one of those. So negative 2 to the 5th power, it's negative 2 times negative 2 times negative 2 and so forth, 5 times. They'll give you a negative 32. X to the 15 is perfectly simplified. Y to the minus 10 cannot be left in that form because it's a negative exponent. And so I would get y to the 10th power on the bottom. So now it's no longer a negative. All right, units behave identically to variables when converting and simplifying. I love that he covers this because this is very, very, very important in all your science classes, by the way. And I am super big on dimension, this term right here, dimensional analysis. I can solve problems sometimes just by dimensions or units only. Dimensional analysis is a term applied to performing operations with units. This is a very common equation that you see in lots of science. Distance is equal to the rate, the speed at which you're traveling, times the time. It is a formula that relates distance, rates, and time. So rate might be miles per hour, time might be in hours. That gives you how many miles that you have traveled. So, all right, so we need to perform the indicated unit conversions. There are 365 days in a normal year. I want to know how many seconds there are. Okay, so 365 days. I need to get that to seconds. So what do? Well, How many hours are in a day? I know that one day is equal to 24 hours. Okay. Super important to write out your units. Don't just write this 24 over 1, okay, because you need to cancel. So how did I know to multiply by 24 and divide by 1? Because I just got rid of my day, okay? I'm now in hours. So that's the unit left. That's not what I want though, because I need to be in seconds. Well, let's keep going. 1 hour, how did I know to put on the bottom? Because I know that I need hours to cancel, equals 60 minutes. So I got to multiply by that. Continuing on, I'm not there yet. I have 1 minute is equal to 60 seconds. Now what can I do with all my units? I see minutes cancel, I see hours cancel, and I notice that the only unit left is seconds on top. And since that's what they're asking, I'm feeling pretty good about that. Then I can plug in all that. So 365 times 24 times 60 times 60 will give me my answer. And that will give me 31,536,000 seconds. A volume of a box is 3 cubic feet. So I have 3 feet cubed. That's the same thing as a cubic foot. What is the volume of box in cubic inches? Okay. Well, what do I know about foot to inches? I know that 1 foot equals 12 inches. Now, how did I know to put the foot on the bottom? Well, that is because I need the feet to cancel and convert to inches. So one of these feet that are in that cubic feet has canceled, but I'm left with 2 more. So I have to do this how many times? I have to do this 3 times total, so 2 more times. Now, I have gotten to the point, because I've done so many of them, that you can just multiply it times the conversion factor, 12 inches over 1 feet, cube the whole entire thing. And your rules from exponents will tell you that I now have feet cubed on the bottom, inches cubed on top, and I just have to take that 12 and cube it, okay? At any rate, now all my feet cancel, and I'm left with 3 inches on top, which times each other will give me inches cubed, and that will give me 5,184 inches cubed. Now, if you use my approach down here, make sure that you remember your 12 is cubed, because I got to take that 12 to the cubed power, and you will get the same exact answer. And when you are canceling, you'll see that I have feet cubed on the bottom, I have inches cubed on top. If the bicycle has been ridden at a rate, an average rate of 100, oops, I'm on the wrong one here. If the bicycle has been ridden at a rate of 20 miles per hour, 20 miles per hour, at what rate is it being ridden in feet per second? Okay, so I have 20 miles. This word per means divided by, per hour. There it is. I want to know how many feet per second that is. And they've been kind to give us this conversion factor. So I happen to know based on that, I have 1 mile. How did I know to put it on the bottom? Because I need miles to cancel, is equal to 5,280 feet. Okay, they wanted it in seconds. Miles has canceled, but I'm still left with feet per hour right now. And that's not what I want. So I got to keep going. I know that 1 hour is equal to 60 minutes. And that's not good enough because I wanted it in seconds. Now I'm left in minutes on the bottom. So now I have to go 1 minute. How did I know to put it on top? Because I need minutes to cancel, is equal to 60 seconds. So now my minutes cancel. So then I typically have folks go through and evaluate, what am I left with? I have feet on the top and seconds on the bottom. Is that in the term that they wanted it in? Feet per second. Per, that's the divided by. So then I would take 20 times 5,280 divided by 60 divided by 60. And that will give me your answer, which is 29.33 feet per second. All right, if a car drives an average rate of 100 kilometers per hour for 20 seconds, how many meters did it travel? Well, I need the total distance. That's what they want to know, which is equal to the rate times the time. Even if I didn't know that equation, I could probably figure this out with units alone. So I had 100 kilometers per hour for 20 seconds. So I've got to multiply that 20 seconds. How do I know that? Because my times are going to cancel and I'm going to have a unit of distance for my answer. Except the problem is I have hours and seconds. So I've got to convert the hours and seconds. So if I multiply by for every hour, I have 3,600 seconds. 60 times 60, right? So what happens now? My hours cancel. My seconds cancel. Now I'm left with units of distance on top. I'm getting closer because that's what I wanted to know, a unit of distance, except that I don't have units of meters yet. That gives me units of kilometers. So how many kilometers are there in a meter? Well, for every 1 kilometer, there is 1,000 meters. And that should give me 556 meters. Okay, a couple more. Practice SAT questions. Nate walks 25 meters in 13.7 seconds. If he walks at the same rate, okay, which of the following is closest to the distance that he walks in 4 minutes? All right, so I have to figure this out. I've got 25 meters in 13.7 seconds. And I've got to multiply it times 4 minutes. Okay, so we can say, all right, I've got to get these minutes and seconds to cancel so that I know the total distance. So what do? I say, okay, 1 minute equals 60 seconds. I've multiplied it by that conversion. I'll look at my unit. Seconds cancels, minute cancels. I'm left in units of meters. And so that is going to give me my answer of 437.96. And what is that closest to? 450 meters. Sometimes they'll give you units that you've never seen before. The pes, a Roman measure of length, is approximately equal to 11.65 inches. I personally would say 1 pes equals 11.65 inches. It is also equivalent to 16 smaller Roman units called digits. It is also equivalent to 16 smaller Roman units called digits. So to me, that says 1 pes equals 16 digits. Based on these relationships, 75 Roman digits is equivalent to how many feet? 75 digits equals how many feet? I got to get digits to feet. Well, first thing I can do is go from digits to peses. So I'm going to multiply 1 pes over 16 digits. How did I know to put the digits on the bottom? Because I need digits to cancel. Now I'm in units of peses. I'm trying to get to feet. Well, I have a conversion unit up here that they gave me pes to inches. That's getting me a step closer. So I would multiply 1 pes. How did I know to put that on the bottom? Because I need my peses to cancel. Gives me 11.65 inches. Now I'm getting closer. Peses cancel. I'm left with inches on top. I need to then multiply by 12 inches, gives me 1 foot. Inches cancel. I'm left with feet. That's the only thing left. So I'll make 75 times 11.65 divided by 16 divided by 12, and that gives me 14.55 feet to the nearest hundredth. So that would give me the answer that that's to the hundredth. So we're good to go. Oh, I think if you entered that into your calculator, you would get this, but they wanted it to the nearest hundredth. Okay. All right. That's all what I got for you today. Message me if you have any questions.